Good morning, all. I welcome you all for the next lecture series. In this series, we are going to discuss about transmission line, and especially we are going to discuss a short transmission line. I think for the last class we have discussed about type of transmission lines. So, and what is transmission line? Anyone can say what is transmission line? Yeah, of course, it is a conductor. It is a system to where the conductors and supported by the utility, and it will be used to transfer from power from the generation area to the substation or to the consumers. So this is what we are saying. It is a transmission line, and we can use for this to transmit the power from generation area to transmission, that is substation, or to the consumers. So in that, based on the kilometers, we are discussed three type of transmission lines. So anyone can say the transmission line type of transmission lines. So yes, there's a short transmission line and medium transmission line and long transmission line. Okay. So anyone can say short transmission line kilometers. Yes, it is used for the 80 kilometers, less than 80 kilometers or 50 miles. Very good. And for the medium transmission line is above 80 kilometers up to 125 kilometers. And above 125 kilometers, we can say it is the long transmission line. So now we have to see in detail about short transmission line. So now only we can say that is discussed. Below 80 kilometer, we can say it is a short transmission line, and voltage is less than 69 kV, and which is negligible of charging current, line charging current. Based on that, we are neglecting the capacitance. That is, shunt capacitance is not used in this short transmission line. And normally in short transmission line, the capacitor is negligible. Capacitance, this type of line is neglected. And other parameters like electrical resistance, inductor, and other parameters are lumped together. For lumped circuit, we can draw the vector diagram. Right, see the vector diagram here. I have to show you, and this is the transmission line, so which consists of here we are mentioning Vs is the sending in voltage, and Vr is the receiving in voltage, and Is is the sending in current, Ir is the receiving in the current. So in between we are considering the parameters resistance and inductor, and we can say it is a z parameter, z value, that is r plus jx is equal to z. So for these values, we are drawing the vector diagram. So vector diagram consists of sending in voltage current and receiving in voltage current, along with this the component. So let's see how can we draw the vector diagram. So normally we know that we can take reference as a current or voltage. Here in this diagram we are taking considering receiving and current is reference voltage. So that is this line, we can say it is the reference current IR. So normally we are taking a current as reference. Definitely the proportional voltage VR is leading some angle. That angle we can say it is the phi R. The power factor, voltage and angle between the current and the voltage, that is an angle that we call it as the power factor. Here we are mentioning phi R. And again we have to include all other parameters, that is we need a sending in voltage. So first we have to refer IR is the reference line, and reference voltage is, that is receiving in voltage is leading with some angle. So from that we have to draw the other components, that is which consist of IR Z plus IR JX. So normally the IR is parallel with this current. So from this line we have to extract the line from parallel with IR, that we can say it is the IRR. And the other parameter we have, that is IRJX. So normally the X is the reactance component, which is considering 90-degree with the real values. That is IR, from the IR we have to draw the line 90-degree IRJX. So after that we have to join from the IRJX to the origin. We can get the value of Vs. That is Vs consists of Vr plus IRR plus IRJXR. So this is how we are draw the vector diagram, and from this angle we can say it is the phi s. Phi s is the receiving end sending end power factor, and phi r is the receiving end power factor. So this is how the procedure we can draw the vector diagram for short transmission line. And normally the shunt, we are neglecting the shunt capacitance. So Is is equal to IR, sending in the current is equal to receiving current, and approximately we can draw the transmission line from the phasor diagram: VR plus IR into R cos phi R plus IR X sin phi R. So we can rewrite this, that is Vs is equal to VR plus IR R cos phi R plus IR plus IR into X sin phi R. So from this we are calculating the voltage regulation and efficiency. So voltage regulation formula is Vs minus Vr divided by Vr into 100, and efficiency is sending end receiving end power divided by sending end power A plus losses. So this is how we are calculating the efficiency and regulation for the short transmission line. So I think for in this lecture you have learned few informations about transmission line, especially for transmission line. How can we classify it, why it is called a transmission short transmission line, and it neglecting the capacitance shunt capacitance because of the line charging current is negligible. So based on this, Is is equal to IR, and Vs is equal to Vr plus IRR plus IRJXR. So for these equations, we have draw the vector diagram, and we discussed the how to draw the vector diagram. So and how can you how to calculate the voltage regulation and the efficiency. All those things we have discussed in this classes. We can see in the next class ABCD parameter. Thank you all.